Benefits. What is OLTP? What is OLAP? OLTP is nothing but online transaction process, and OLAP is online analysis process. OLTP is where you are doing your current transactions. OLAP is the historical process. This one we know. Okay, next we are going dimension table, fact table. We need some more time to understand. That's why I'm passing that stage. Now just understand uh, what is nothing but object storage and what is block storage. Okay. As we discussed earlier, uh, whatever we are having in database, so a database, all the memory is going to be allocated like block storage. We have already discussed that. But what you remembered the block size is 128 MB? I told in the second class. So the block size is 128 MB. Total 1 GB is divided into number of blocks, 8 blocks, I think. So
Yeah.
this, yeah. So this the same concept we are discussing now. So for this block storage, we are having storage in the blocks, means file is split and stored in fixed size of blocks. So this is a block storage. What is HTTP interface? Like where you are using web browsing and everything, right? There it is storing in the object storage. So there is a lot more difference between object storage and block storage. So block storage, it will store into the number of blocks, and capacity can be increased by adding more number of nodes. So each block we are having 128 MB. Previously for HDFS system, it is 64 MB. Now they have converted into 128 MB, and it is in your hand, like you can customize which block size you want to take. But 128 MB is commonly people are taking, but it is depends on your architect, like how he wants that memory should be allocated and all. As a data engineer, we don't need to change the configuration, but if you want to change it, we can change that, but not here. It is at the architect level. Okay. So capacity can be increased by adding more number of nodes in the block storage. What are the nodes and why it is like that? We are going now. We can see it. Okay. So suitable for applications which require high IOPs, database transactional data. What is transactional data? Where you are having the OLTP. OLTPs are source. OLAPs are destination. Okay. So at the source side, how you are having in the block storage. So OLTP or databases, everything, even SQL DB, Oracle DB, whatever you are having databases, all these databases are having block storage. Okay. And again, when you are using analysis purpose, or you are using something which is not like database, which is like a file system, there you are having object storage. Object storage is nothing but file storage. Here you are having block storage, and here you are having uh, file storage, which is HTTP based interface. And files are distributed in different physical nodes. Okay. So here you are, if you are saying object storage means it is completely file storage. If you are saying block storage means it is database. That is the main difference. So whenever you are using OLTP and whenever you are using databases, MPP databases would be there, data warehouses. In the data warehouses, you are having all the block storage, because whatever are so input would be, but the ultimate destination would be the data warehouse. So in the data warehouse, you are having block storage. And in HDFS system, Hadoop distributed file system, you are having block storage. But in big data, whatever we are using, in big data, we are having both object storage and block storage. So in big data, we are using object and block storage. But in the databases, we are using block storage. It means file is splitting into number of fixed size blocks. Here it is stored in the nodes, like it is the file version. Okay. The complete file is going to be stored here. File is not going to split anywhere. Here file we are splitting, but here the entire file is stored in one object. This is object storage. This is the block storage. just how the process will be, just we can see once. Then we can go to the HDFS architecture. This is a source, and we are having, this is a big data network. Okay. You see here, this one how big data looks. Okay. Suppose if you are considering this as a source, source would be anything. So from the source, you are getting data over the network in big data. Am I right? So we are not connecting physically to anything. Previously, it was like that we are having physical connections, but now if you are connecting to an on-prem system is nothing but what we will discuss it. But what in brief, what I'm saying is on-prem system is somebody's system. From that, like suppose if we are having a banking system, okay. So for there it is an on-prem system. From their system to into our system, we are connecting virtually, right? So we are not connecting, any physical connection would be there, won't be there, like any wires or something. It's not like that, right? So we are configuring something, and we are connecting to their banking systems, and we are getting their data into our system to process their data. Not only banking, see any industry, we are connecting to them and we are getting the data. Otherwise, they will connect to our systems and they'll push the data into our systems. That is the process we are having. So here so here we are getting the data into our big data. How we are getting? Through over the network, over the network. And next, I'm having file system here, where we are processing all the data. We are processing it in the big data is nothing but file system. Wherever if you see the big data concept, that is nothing but big data is nothing but file system. So we are receiving into the file system. What is big data? Big data is nothing but what kind of storage we are having? We are having block storage plus object storage. This is nothing but big data. Whereas whenever you are considering any DBs, MPPs, okay, any DBs, and what are MPPs? We'll go through that. Okay, uh, any DBs or MPPs, any OLTP services. What we are having? We are having the block storage. We will store the data in the blocks. Okay, this is so here we are having file system. File system is nothing but we are having big data. Big data is nothing but both block and object storage we are having. So here from here to which one we need? We need one database to store the data. Database to store the data. This is what. So here what you will have? You will have when IO process, read and write operations. Why we need big data? What is the purpose of big data? Purpose of big data is writing once and read multiple times for the analysis of data. What is the purpose of big data tools and big data we are doing? Write once, read multiple times. Read multiple times for the analysis of large volumes of data. This is generally, you should have this picture in your mind. Okay, now we need to understand exactly how the data engineering process takes place. This thing you should remember through the entire class, and whenever you are working through the entire your time. Don't never forget this diagram. It should be in your mind. Okay, what is this? We have discussed this already. This is the source, different sources. Okay, so the sources may be any SAP, anything. Okay, it can be SAP or any Salesforce or mainframes or any on-prem systems or any DBs. Okay, anything would be the source. Any ERPs, non-ERPs, anything would be the source. Yeah. Salesforce or mainframes. We are getting data from there. That's it. No need to worry about the source. Or it can be any on-prem or any DB. Okay. So we are getting the data from different sources. And what we are having now, we are having inside we are having one data lake, which is data we need to store somewhere, right? Data lake, which is unlimited. Okay, data lake, which is data storage. Okay, nothing. Data lake, which is unlimited. You can store how much you need. Because this is big data, you will have large volumes of data. And what we are doing, we are where we are doing on the cloud. What is cloud and all? We can see cloud. And here we are having unlimited storage. Unlimited storage. Okay. So here, one advantage of this big data is you can store any type of file. You can store any type of file. Okay. There is no restriction. You need this or this one like that. Okay. So inside this, what we are having is, I'm just taking another color. It's all black and white. Inside this, you are having one landing layer. Landing layer. After that, you will have one staging layer. Okay, staging. Okay, and after that, you will have one MPP database. You are having inside the data lake or inside cloud, you are having one landing and this one is staging, and this one is one massively parallel processing database, MPPDB. So, and at the end, we are having Power BI. Why? Because Power BI will take all the refined data to give the dashboards. Okay, this is what we are having our entire data engineering. We are doing any project. This would be like this one. So we are connecting now. This connection is nothing but what? This is nothing but ingestion. Ingestion. Who will take care of this ingestion?
Engineer.
Mm, Right. ETL tool, right? That is, I have given you that type. This is our final project. So this is landing and we are taking some staging. So all this is staging only. So staging is nothing but I already explained to you, like whenever a Swiggy delivery boy, he was taking his food to deliver to the customer, he is placing that food in the one temporary vehicle, right? That kind of vehicle we are using as a Spark. So that is a staging. So to landing layer, we are who is doing this? Either it is Databricks or it is Azure Data Factory. So these two are what they were doing. They were ingesting the data into the landing layer, or they were orchestrating the data into the landing layer. If you heard those words, ingestion, orchestration, both are same. So you are orchestrating the data into the landing layer means this particular, whatever the input you are having, see here, you are having inputs. Oh my God. So you are having different inputs. Either it may be on-prem system or any local folders or any DBs you are having, okay? So this thing you are connecting to the landing layer. Landing layer you are connecting means you are getting data from here to here through one ingestion tool. That is ETL tool. That is nothing but extract, transform and load. It will do extraction and it will load into the landing layer. Or sometimes what happens is you will get the data from here and you will load through ADF into the Power BI directly. So you don't need all these things. This is the old projects. Now also I'm working on this, some kind of that kind of projects are there still, and they were hiring you for that also. So Azure Data Factory, what it will do is it will take data from source, and what it will do is it will transform inside and it will load into directly Power BI. That is possible. And another one is through Databricks. So it will take the data and it will give the data to the, we will connect Databricks to the ADF, and ADF to Databricks, the data would be transferred. From here we are having medallion architecture. In this medallion architecture, what we are doing, we are loading and we are cleaning everything in the staging. And then we are giving this to Power BI. That's what we need to understand. So, okay. So landing. So here in the landing, if you are considering any files, any kind of file, the files would be given here. The files would be either it is CSV, text, JSON files, or XLSX, any kind of file. It can be taken. Obviously, you are right. Data engineer is only doing everything. But here, that process, whatever process we are dealing with, right? That process you call it as ingestion. This ingestion is done by an ingestion tool. That tool may be either it may be ADF or it may be Databricks or somewhere it may be Informatica. There are many ETL tools who are doing this, but mainly we are concentrating on Azure tools. Azure tools is nothing but Azure Data Factory, and we are having Databricks, Azure Databricks. So we can use those two for the ingestion purpose. There it is. I'm just mentioning Data Factory. Mm, And another one is Databricks. Mm, So this is the ingestion tools. And this is all it. And here we are having staging is nothing but what? Staging is nothing but temporary memory. Temporary memory. Okay, this is a Power BI. So it is connected to the Power BI. Or Power BI can connect to the data lake. This is what we are having. This is the main thing you need to remember. And next, what are the MPP data warehouses?
Quick question.
Yes.
So is it called temporary memory because the data is only there through the ingestion period, and then it's either taken into Power BI or whichever data processing tool, data analysis tool it's gonna end up in?
Spark is an in-memory processing engine. We didn't go through it there, but it is a good question you have asked. That is right. So Spark is nothing but in-memory processing engine. I told Spark is the staging area where we are doing all the transformations and all. This is a big concept, but I'm just briefing it, and we will go through it in the 2 to 3 classes. We'll go through it, but for your curiosity, I'm explaining here. So Spark is nothing but you need to remember that Spark is an in-memory processing engine. In memory. Why we went for Spark? That is a very big story, because previously what we did is in MapReduce. So first concept is MapReduce. We will discuss that, but just I'm giving brief in 2 minutes. So in MapReduce, what we are doing is we are reading the IO operations, like we are transferring the data from disk to in memory, means RAM. Okay, disk is nothing but ROM, read only memory, right? Permanent. And in memory is nothing but RAM. In memory. If you are calling in memory. So in memory is nothing but RAM. Random access memory. So it is temporary, right? RAM is a temporary memory. So what happened in MapReduce is IO operations, it is taking place from disk to in memory and in memory to disk again. So what happened is if you are doing like that, the process is going to be very late. Okay. If you see here, this is Spark. Why Spark? So see here, if you are, so disk IO operation, IO for each repetition, slow when executing many small iterations. So for each and every command you are running and each and everything, it will come from disk to in memory. Again, in memory to disk, disk to in memory to disk, like this staging, stage 1, stage 2, stage 3, it is like that. So what happens is it will go slow. That's why we are moving to Spark. What Spark will do is, it will directly work everything in the in-memory process. You can see here. Only one time we are taking from data from disk, HDFS or anywhere. From disk to every operation entirely is happening inside RAM. RAM is nothing but temporary memory. If you are saying in memory means temporary memory. So what I said, Spark is an in-memory processing engine. So in-memory processing engine means where we are working on temporary memory. That's why it is very speed. Not writing anything into the disk. Okay, that's why staging, where we are doing the staging inside the Spark. So what is Spark? Spark is a temporary memory engine. So you will do every operation inside the in-memory. In-memory is nothing but random access memory. Random access memory also called as temporary memory, right? Is it clear?
Yes. Thank you.
Just want to say something, I forgot. Okay, what I'm saying. Spark is in memory processing engine. So we are storing all the data in Spark. I just want to say something. Okay. So MPP data warehouses. I just using DW for data warehouse and DB for the database. Okay. So we are having different MPPs for data warehouses. One is Redshift. It is by Amazon. So ultimately, in our project, if you see that you are storing somewhere in the data warehouse, finally, right? So that data warehouse is nothing but uh, MPP. MPP is nothing but massively parallelly processing. So entire data is going to be processed over the nodes. Whatever synapse we are discussing, whenever we went to the synapse, then you can understand exactly what is MPP. Synapse is one of the MPP. And the second one is BigQuery. BigQuery is by Google. It is provided by Google. Third one is Synapse. Synapse is by Azure. This is also called as Azure Synapse Analytical Platform. Fourth one is third party, which is Snowflake. If you want Snowflake classes, you can ask me. I can teach you that also, which is a third party. So these are the MPP data warehouses. For Amazon, those who are using Amazon cloud, they will use Redshift. If they are using AWS, Amazon Web Services, they will use this Redshift. If somebody they were using GCS, Google Cloud Services, they will use BigQuery. And now we are using Azure, right? So we are using Azure Synapse. Snowflake is also a good data warehouse. People are using that. Still, many more openings are there for the Snowflake. Now, this is suppose just go to that. I just want to show you something, how the data is going to be splitting and processing. Okay, I'm just here. It's okay. We can discuss that in little more. You will get confused. Okay, just I'm just giving you another one. So just we are going through to the HDFS architecture. Now it is clear that object storage and block storage. Okay, in discussing everything also, I'll point out to how it is dividing into blocks, how it is dividing into object. While doing the project also, you can understand. Okay, don't worry for that. But as of now, you just remember like this. Block storage is nothing but it is a file which is stored in a fixed size of blocks. What is object storage? Object storage, each file is stored in one object. That's it. So the file won't be splitting. Here it is split and store, block storage. Okay. So what is HDFS? HDFS is nothing but Hadoop distributed file system. Suppose if Hadoop client is having 200 TB file, they want to store that in the HDFS system. Okay. 200 terabyte file. That is not a small file. That is very big file. So now what Hadoop is saying, okay, that is big data. I will need to distribute that across a cluster. How Hadoop distributes across the cluster? By using block storage. That we know. Okay. So next, sounds risky. What happens if a drive fails? So if you are making that into number of parts, okay, I'm just making the 200 terabytes file into number of pieces. Okay. Now just think like if you are having one block or one page and you are making that as number of pieces. Now, if suddenly one piece went off, like suddenly one drive which is working for that particular data, if that failed, what happened? That entire data is going to be erased. So data is very crucial for us because we can't retrieve once the data got erased. So what is it? It looks like risky. It was saying that Hadoop client is saying that it is risky. Then what HDF is saying, no need to worry. I'm designed for failover. How it is designed for failover, we will see in the architecture. Okay. So what HDFS is saying, you don't worry. I'm having another backup. So due to that, you don't need to get deleted the data. So the data would be safe with me. Okay. So that's fine. It is saying like that. How it is how it is making the data into number of partitions, we can see that now. So key ideas behind HDFS, Hadoop distributed file system. Any distributed file system, how it stores, it splits and stores the data. So write once, read multiple times. This is the main motto behind any big data, right? Write once, read many times. Divide files into big blocks and distribute across the cluster. So what is cluster? Cluster is nothing but a compute. And what is a compute? A processor, network, and memory, right? Am I right? What is a compute? Processor, network, and memory, right? It's okay. So dividing files into big blocks and distribute across the cluster. Store multiple replicas of each block for reliability. So in Hadoop, the main thing here is how it stores, how it is designed for failover is, it is storing the replicas of each block. It's not storing only one block in one node and it is living like that. See, you can see here, if you see 1, 2, 3, 4, total how many blocks it is there? 1, 2, 3, 4, 3 blocks are there. But how it is storing the entire blocks? It is storing one here, okay, two here, two again here, two. So how many replicas it has taken? 3 replicas of each node. That is standard one. You can increase number of replicas, but 3 is the standard one. So 1, 1, 1. 1 is stored in 3 different nodes. This is node, okay? One node, 1, 2, 3, 4, 5, 6 nodes. Okay, one is stored here, one is stored here, one is stored here. If one failed, okay, this first node failed, will you able to retrieve the uh, first block? Yes, because we are having here and here also. In fourth also we are having here and here. Okay, suppose if this one failed, 2 and 3. So you can get it from different node. This is nothing but a replication. So when I'm talking about replication, you must get one doubt in your brain. Who will ask that? I'll wait till 2 minutes after this concept I explained. Okay. So store multiple replicas for each block for reliability. Programs can ask where do the pieces of my file live. Okay. So definitely, right? We did all pieces and we stored across the cluster through different nodes. That's fine. The program will ask, right, where it is. So it is given through an ID would be there. That ID can be given to the metadata. Okay, what is metadata and all? We'll see now. This is the HDFS architecture. Before going into this, what I will do is I'll explain through one picture for you. Then it would be more easy to understand. I'm having client, right? HDFS client. If you understand HDFS architecture completely, you will be more familiar with Spark architecture. Our main motto is to go to the Spark architecture, not HDFS architecture. But why we are going to HDFS architecture is HDFS is implemented before Spark. From the HDFS only, we have did some modifications, changes into the Spark, and Spark arrived. So you need to understand HDFS better. By understanding this, you can get more knowledge on Spark, because if you remember this, that is very easy. Okay. And one suggestion from my end is never ever remember anything blindly. Just understand the logic behind that for everything. Okay. Then only it would be easy for you. Okay. I'm having one client. Which client it is? We are discussing HDFS files. HDFS client. Now, what I'm doing is this client is sending data to the HDFS system. This would be a little big because I need to give one. So see here, I'm giving one master node would be here. Master node. And I'm taking 4 data nodes. 1, 2, 3. So before I told you like what is the block size for any system we are taking 128 MB. Yes, very good. So for HDFS also block size is 128. Similarly we will use HDFS block size also 128. Okay. So any HDFS client to interact with or reading and writing data into the HDFS file system, we are giving the HDFS client. What he will do? He will any HDFS client. Take another color. Okay. It's okay. Any HDFS client or any distributed, not only HDFS or any DFS, distributed file system client to interact with HDFS, to interact with HDFS system for reading and writing data into HDFS client system. This file system. The intention of this HDFS client is this client needs to interact with HDFS to store their data into the HDFS system. So now we are having master node. This is nothing but master node. These are data nodes, slave nodes. Okay. So total, suppose I'm taking 1 GB file here. 1 GB file. One second. Sorry. So I'm having master node, data nodes, slave nodes. So in this, I need to give you the block size and replication here, right? So whenever you are dealing with this, you need to give, first thing is, oh my God. Block size and replication. We are taking 120 HDFS block size. We are taking as default HDFS block size. Today's class will go 10 minutes. Okay, 7:10 till HDFS block size would be 128 MB. It is a default one. Okay, this master node will have the block size in it and replication factor. Replication factor default would be 3. Okay, means it will store 3 times. So I'm having total 1 GB file. Okay, for 1 GB file, how many files you will get? We have discussed, right? So 1 GB file we are having 1024 MB. So it is going to be 8 files. It would be 1, 2, 3, 4, 5, 6, 7, 8. See? So this 8 files are going to distribute across this data nodes. Suppose if I'm giving here, okay, it would be somewhat tough, but try to understand because writing in here it is different. Taking one, and it is not like it will store in sequence, it will store in random. Okay, so 3, 4. So suppose here I'm taking again 5, 6, 7, 8. This, how many times it will store? Now, again here 1. Okay. 2, 3. Each node will have all the information. Even one node fails, then other node will work for this. Okay. So it is completely 3 times it will take. I'm just explaining one. Suppose if I'm taking fourth partition, fourth block. Okay, this fourth block will repeat 3 times. So see here 1, 4. Second one I'm giving 4 here. You can take here 4. 3 times. Each one will repeat 3 times. Here it came 1, 2, 3. Suppose I'm taking another one in different color, you can understand. Suppose I'm taking 7. Once already it is here. So it will 3 nodes would be there. It is not like that we are having at one place, and if that data node fail, everything fails. It is not like that. So it would be like that. You will have that particular block in 3 different data nodes. So if one data node fails, no worry, another 2 will be there for you. Okay. So this is what actually, this is nothing but you can call it as master and slave architecture. If I'm saying master and slave architecture, HDFS architecture is master and slave architecture. So you will have a master node, and okay, that master node you are having slave nodes. If you understand this concept, it would be easy for you to understand the remaining. So it is like this. Statement.
Hi, Divya.
Yeah.
Two questions here. Like for each data node or slave node contains how many blocks? Like I mean, you can say size. Like for example, one block is 128 MB. So for one node, how many blocks it will be there?
Mm.
Is there any standard? And the second question is like if we store everything in 3 replicas, it will surely get. I mean, cost issue, right? You can say storage. We need to buy more storage again and again.
That is what I'm expecting. That's what I told before. So if I'm saying 3 replicas, 4 replicas, 5 replicas, multiple replicas, then it is already vast data, right? And
Yeah.
again, you are storing in different replicas. Then you tell me how you are dealing in big data. Do you have any idea? No, that is fine. I'll explain, but just give your brain some this one. James, I think James can answer. No, that's fine. Even if you are not able to answer, that is fine. Have you like ever tried in your mobile or in like very large images or videos, or you are sending over some Bluetooth or something? Have you
Yeah.
remember that one? Have you did that? Do you remember? No.
I mean, by connecting both
No.
phones
Suppose if
Bluetooth.
you are having very big files, if you want to send through email, how you will send? Have you tried that? No. In BTech or somewhere? No. You will compress that, right? Compress to
Zip
a zip
file.
folder, zip file, right?
Yeah.
So in the same way, in big data, it is not going to store directly. 99% compressed files you are storing. If I'm saying 1 GB file, it would be nearly 1 MB, because 99% is going to be compressed. For that, what are the compression techniques? We are having Snappy, ZZip. Many compression techniques are there. By using those techniques, big data will compress the data and load it. This is what. This is
So,
the actually.
so
Yeah.
every time whenever query, it needs to unzip and provide it.
No. It's not zipping and unzipping. That is for your emails.
Okay.
Okay. Here you don't zip and you don't do anything. It will it will automatically compress it, because when you are working with the tools, then you will get to know there would be one snappy algorithm. So what it will do is it will automatically compress it. Even if you are using the Azure Data Factory also, there would be snappy algorithm running at back end.
Okay.
So you can't see with your bare eyes. Like it is not like that you can see it. So it is like that at the background, whatever you are having, because we will discuss like what is the big data file formats. Then you will come to know how it is going to compress the files. So if I'm saying 200 terabytes, it's not going to be 200 terabytes. It's going to be compressed version of 200 terabytes. So it's almost 1% data is 1% data will be stored in this master node metadata.
Okay.
Remaining everything is compressed. First question you asked something I forgot.
Yeah, I mean, for each data node or master node contain how many blocks? Is there any standard size?
It is not like that, no standard size. It depends on your number of nodes. So each node, you will increase this number of nodes. I'm just giving 4 here due to the size. Here I'm not able to draw everything, right? So it's not like that. Everything is configurable. They can take 4, they can take 5 files, they can take 6, they can take 100 also. It depends on your number of cores in your processor. Okay, so there is no standard for that.
I mean, for data node, how many blocks? That is also there in master.
How many blocks?
Blocks
Okay, in one
in
data node.
one data node, correct.
That is what you don't have any standard for that. It
Okay.
depends on the architect. Just 128 MB is a fixed one. Everybody will use that 128 MB. That also in HDFS, previously it was 64 MB only. Now they increased it to 128 MB. So there is no limit for this. Like we can
Okay.
take how many. It depends on the architect level, because they will see all the cost. Everybody is running around the cost only, because
Yeah.
they want to do optimized things. Even in your organization, you can see my organization. I can give you the best example. I'm daily doing some data reconciliation. For that, nearly it's going to go. ADF needs to go through nearly some 3 million rows daily. So
Okay.
for that, actually, if you are using really ADF, for them it will cost $10 like that only. But for that only data reconciliation part, we are getting $2,000 per month for that cost. So they kept one meeting and they were asking any other ways, because this data reconciliation is very small part. For that, I'm paying $2,000. So my budget is going more. Like that, people will look about their cost things, even in industry. That's why they don't give access to everybody, everything. It will increase the cost. They need to pay, right? Pay as you
Yeah.
go. They used to take industrial pay as you go. When we open the Azure Data Factory and everything, you will get to know what is this. Okay? There is no such limit like this. It depends on architect and their budget and everything. There would be like that. Okay.
Thanks.
Like this, we are going to store in 3 replicas in the in different blocks. So this is a block size, and this is a where we are using block size is 128 MB and replication is 3, and we are storing it across the different data nodes. This is what complete HDFS architecture. But I'll give you some insights for this. So master node is also called as name node or header node. Okay. This is nothing but master node. And big data, and whenever you are calling slave or data node. So big data concept is store once, read multiple times. That is for analyzing multiple times. Reporting team will analyze multiple times. That you need to remember. So what is distribute? What is distribute? So the same concept we are using, not distributed, distributed. So the same concept we are using for MPP data warehouses and any big data clusters. Okay. So whatever this distribution process we are looking into, that the same concept we can use it for massively parallel processing databases or data warehouses and any big data clusters. The same concept. HDFC, HDFS, what is this HDFC? HDFS, any data lakes. And again, don't come for what is data lake. That is a very big concept. We need to learn that. Okay. Everything I can't explain in one single statement, but data lake is storage where we are storing any file. What we are doing, split and process, and then stores across different nodes. This is fine. Why we are storing across different nodes? For the high availability of data. Okay, if some node got failed because this is all cloud, we can't say this is we need to store in one particular node, because that node, when it fails, we don't know. Okay, so HDFS block size we can decrease or increase. HDFS block size we can decrease or increase. Old one is 64 MB. Now it is 128. So it is completely parallel processing. What is nothing but parallel processing? All process will take at one time. Okay. Parallel processing we are taking place. Okay. And how it stores, it depends on your CPU. Depends on your, that's what your question is there, right? Depends on your CPU's capability. If one of the node is not available, if one of the node is not available, you are not getting any question, Sai, you should get one question. I don't know. So if one of the node is not available, then how will you get how will you get the files? Due to replication, right? Due to replication, you will get the files. You will store that in different nodes. That means replication to overcome failures. This is, I'm just summarizing everything, okay? This replication is nothing but what? You can simply say it as backup. So what is the HDFS default replication factor? Would be 3. Why for replication? Replication is for high availability of the data. High availability of data. So it means if you are having source of 1 GB, how many times it's going to be replicate?
3 times.
3 times. Becomes 3 GB. Then what about huge files? Just now discussed, right? What about huge files like 200 TB and all? So boss, don't worry. It will compress and store. Okay. Big data uses compression till 98%. Big data uses. Even now it is 99.9 also came. Big data uses 98% compression. Okay, now let's come to, is it fine to continue for 2 to 3 minutes more?
Yes, please.
sure.
Thank you.
So let's come to the master node. So master node, what it will store? It will store the metadata. What is metadata? Anybody from you?
Data about
Like-
data.
Yeah. So what it will store? It will store the metadata of the data, complete data. It will store the metadata and it will generate block ID. So how it knows, like how the program knows in which node it is storing that particular block information. Program doesn't know. We need to give everything, right? So this block master node work is it will generate the block ID and it will store the metadata. I'll explain you what is the metadata. So it will store the metadata and it will generate the ID of this blocks. So in this, suppose if it is ID number 1, so ID 1 is having 1457 blocks. This is what actually this master node is containing the information. Okay. So how to data node will store the data in the disk here. Okay. Data node will store the data. It is not the in-memory process. That's why I didn't explain anything. See, this is different. Spark is different. So here everything disk, it will store on the disk. So data node stores the data on the disk. This is where actually Spark and HDFS differs. So if it is storing on the disk means the process is going little low. I'm just giving you best example. If you are going to your Google Photos, you can click on the photos and you can see that, okay? But if you are storing that particular photos in any pen drive or something, what you need to do? First of all, storing is a little bit tough. That large kind of memory, and again you are retrieving back from the pen drive to your system. See, that pen drive to system, again it has to load everything and it has to read. That become tough. That is what here it's happening. Because of that only we went to Spark. So this disk storage is little bit slow process and it will consume more memory also. That's what. So the data node stores the data on the disk. And what is the master node is doing? Master node is generating the data nodes IDs. So where it is storing, and the data of the particular metadata you are having in the master node. That you need to remember. And okay, nobody got any question here? Nobody. You said like we are having large data and we are compressing that. That question is answered. Any other question you are getting in your brain? What if master node fails? Because everything is there in the master node. What if master node fails? For that also, there is one more node. Yes, one more node, that is secondary master node.
Like a shadowing.
Exactly. Exactly. Secondary master node. This will take care. Here also you will save one copy. Due to this, HDFS will maintain all the data without losing the data. Why we are struggling this much is we need to store the data and we don't want to lose the data at any cost. That's why we are doing replications and we are storing here and there and everything. So here secondary name node or secondary master node would be there. That will store one copy of the metadata into that. Even this master node fails, there is one backup that will take care of all the slave nodes. This is the HDFS architecture. So one more thing you need to remember here, master node is always in memory, RAM. Data nodes always on disk. That thing you need to remember. So master node is always in memory. Always metadata is stored in files. Okay. So it is not in the blocks. Always metadata. Tomorrow we can discuss what is metadata. Always metadata stores in files, not in blocks. Okay. The data would be stored in blocks. Understood? Tomorrow we can discuss remaining things, but as of now, who will take care of generating this IDs and who will allocate this to this nodes? There is one person between this master node and this slave node. That person is resource manager. Between one person would be here. He will take care about to whom we can distribute and what we are doing, which node is available, which node is failed, and which data is in which node. Like, this resource manager will take care of it. This looks a little bit clumsy, but okay. So between master node and data nodes, there is one person called resource manager. He will take care of available nodes and failed nodes, everything. So that complete nodes information and whom to assign everything. He is like manager to this resources. Okay. So he will assign everything. And for this resource manager, you can go and see there is one website. You can check everything there. Hadoop. Tomorrow we can see this because today time is over. Hadoop.apache.org. You can go Google it. Okay, you will get all the information. Hadoop.apache.org. So here the resource manager name is Jan or Mesos. Okay, but in big data, we don't use this. We will use standalone for Databricks, but for HDFS, we are using Jan or Mesos. This is not for the big data. This is not for the big data. Any queries? I'm wrapping this session. Tomorrow we can see what is process, what is storage and all. Fine.
And thanks.
Yeah, thank you.
Thank you.
Okay.